Hi all, my name is Haseem Ahmed and this is my task 2 of the Sparks internship program. So in this problem we have to predict the optimum number of the clusters in the iris dataset and we have to represent it visually. So basically this is the unsupervised machine learning task and I'm using the iris dataset from the scikit-learn library to predict the optimum number of clusters, and here I'm using the k-means algorithm. So basically in this problem we would be having just the features. So I would be just extracting the features from the iris dataset, and initially we won't have the target variable to train our dataset, and at the end we would be like predicting our target or species depending on these features. So here I have imported the iris dataset and loaded the data into the data frame. These are the first 5 rows of my features of my data which I have imported from the iris dataset. So initially I'm just seeing that my dataset doesn't have any missing values, which is really good. Otherwise I would have to normalize my data. So here I'm using the elbow technique. Basically in this technique what we are doing is that we are calculating the sum of squared errors and we're increasing the number of clusters in every iteration, and we have to determine that point where our sum of squared errors doesn't change significantly after a certain point. So what I'm doing here is that I'm taking the range, which is basically the number of clusters. So I'm using the for loop, and in every iteration I am increasing the number of clusters and then calculating the sum of squared errors for those clusters. So using the matplotlib library I am plotting the sum of squared errors on my y-axis and number of clusters on my x-axis. As you can see from the graph, this visual representation tells us that this is the elbow point. After this point there isn't any significant decrease in the sum of squared errors, although there is some decrease, but that decrease isn't significant after every iteration. So at this point where the elbow is occurring, the number of clusters is 3, so we would be taking the optimum number of clusters as 3. So here we would be creating our model with the optimum number of clusters, which is 3, and then predicting the unique species in our dataset. So after our data is trained, we are getting an array here, as you can see. So our data is categorized into 3 different values. So we can categorize our data into different clusters based on these values. So in my data frame I am adding a column for the cluster, and then like you can see that my row 1 is from cluster 1, and like here like every row is from cluster 1. So what are these? Basically these are from the originally my iris dataset has the target variable, but for this problem I'm not using the target variables for training my data. But we can see that from the target variable and target names that these are divided into three different species. So 0 is for Setosa, 1 is for versicolor, and 2 is for Virginica. So what I could do is that I could create a separate data frame for each cluster, and then I could plot them on a scatter plot. So for this, I'm creating three different clusters and dividing my data set into three different frames, as you can see. And here I'm using three different colors to represent my three different clusters. I will be for the problem, as the problems statement suggests only to use two of the features to represent it visually. So I'm using the sepal length and sepal width. So here is my visual representation of these three clusters, which is formed from this dataset. Thank you. That's all for today. Stay tuned for more exciting tasks coming ahead.